Okay, what's up everybody? Today we're talking about thermoelectric coolers, often abbreviated as TE coolers. Now, what I have in my hand right here is a small TE cooler, also called a Peltier chip or module. Now, thermoelectric cooling is a pretty interesting phenomenon. What happens is that you have two different materials, and when you apply a DC voltage across them, you get heat flow from one side to the other. The scientific effect is called the Peltier effect, but don't worry, we're not going to be getting into the physics or math here. What's important is that this is a solid state cooling device, so no refrigerants, no moving parts needed, and when you apply the voltage across these two wires across the device, you get heat flow from one side to the other. That's it. So here I have this TE cooler that I bought off of Amazon, and when you buy in bulk, so maybe 5 or 10 units, they're only about $4 per unit. Now there's really only two things that you need to know about this. The first is the voltage rating, and the second is the current rating. And so both of those will be available via the data sheet provided when you buy it. Now, as with any electronic device, the data sheet is going to be your best friend. It's going to have all of the information you need. This one, like many devices, has some information printed on the front. You probably can't read it here, but I'll zoom in. And this information, it turns out, is standardized. So any chip that you buy is going to have the same sort of information on it. For this one, the only thing we really care about is the two last digits, which indicates the current rating. This one has a 6 at the end, 06, which means that the maximum current is 6 amps, which is quite a bit of current actually. But really what you should be more concerned with is the operating current, not the max current. And in this case, for this device, it's 4.5 amps roughly. So that's it, a very simple device. Two wires, one you hook to the positive, one you hook to the negative terminal, and pretty soon you'll see one side will start to get cold, one side will get hot. And if you were to reverse the polarity, then the side which is hot and cold would switch. And again, one last time to remind you, this thing uses a lot of current, especially for a small electronic device. 6 amps max, 4.5 working, that's quite a bit. For reference, your USB phone charger probably uses 1 or 2 amps maybe. So make sure that whatever device you're using to power this thing, be it a power supply or some batteries, can handle that amount of current. The other thing to keep in mind is that these things generate a lot of heat, more than you would expect. And so you need to dissipate it very quickly. You can use some sort of a large heat sink, a fan, maybe a combination of both. But if you don't, what you'll notice is that as you power it, you'll quickly start to see one side getting cold, the other hot, but then in probably less than a minute, maybe less than 20 seconds, the cold side will start to get very hot as well. And what's happening here is that the hot side of the device just can't dissipate the heat quickly enough. And so it starts to flow into the cold side of the device until the whole thing starts to heat up. And then you've either fried it or you need to turn it off very quickly. Now, as far as practical uses for these TE coolers, the truth is that they're pretty inferior to anything that uses a vapor refrigerant. So that would be like your home refrigerator or a home AC unit or a window unit. The reason is that these are very inefficient, about 1/4 as efficient as a vapor refrigerant. At the same time, there are significant advantages. The first is that this is a solid state device, so that means no moving parts, little to no maintenance, no refrigerant that could leak or cause environmental concerns. Another, of course, is that they're very small form factors you can see when space is a concern. And the third is that the cooling effect can be very tightly controlled via manipulation of the input current. Now, typical uses for TE coolers might be a mini refrigerator that you would see either in a camping cooler, something you would plug into your car, or even a USB beverage cooler for your desktop. In addition, there's many scientific uses for these coolers. For example, in high-end cameras, like thermal cameras where cooling is necessary, or even spacecraft or satellites. So there you have it, a very brief introduction to a pretty cool device that maybe you haven't heard of before. Hopefully it gave you inspiration just to learn something new or to create a new project at home. As always, I appreciate you watching. See you next time.